Welcome in part 2 of this Bluetooth tutorial with the ESP32. In part 1, we had a look at an app to verify whether or not the transmitter is working correctly. In this part 2, we're going to have a closer look at the receiver and realize ESP32 to ESP32 communication. So you will need two ESP32s to follow along here. We'll start with setting up an ESP32 transmitter as we did in part 1, leaving that running continuously and then so that we can focus on the receiver. In order to make sure that we all have the same code running on the transmitter, we can start off with the code that we used in part number 1. So here's my repository, link of course in the description below, and then just navigate to ESP32 part 1. This is the code for the server, so we'll go ahead and download that. This is in essence the code of part 1. I cleaned it up a little bit, but in essence, it's the exact same. We see here that we have a service UUID and a characteristic UUID. Then basically we create the service, and periodically here in the loop, we write now a new value to the P characteristic. So you see your P characteristic set value, and we wait a second. Very simple. It's just through notify. But let's just upload this and then focus on the receiver first. Before we now get started with the receiver, let's verify briefly that the transmitter is up and running. So as discussed in part 1, we use the NRF Connect app for that. Just briefly connect to the ESP32. And then we see our service, and sure enough, it's counting. So everything's up and running here. I'll just leave this ESP32 as is. And now we take a second ESP32 and program the client. As a starting point for our client, we're going to go to File, then Examples. And under ESP32 BLE Arduino, you can open now BLE Client. This is the example for a client code that is included in the library. The first thing we should do is verify that the UUIDs for the servers and for the characteristic are the same as the ones we're using in the server. As we base the code on the examples of the library, this actually is already the same, but it never hurts to check. Let's briefly go over the code and then adapt it to our needs. First, there's a couple of sets of variables that are defined, and then there's a very important notify callback function. This function is called every time that the server does a notify to its clients. This is then the main function that we'll be adjusting in this code. The next class over here is just for on connect and on disconnect, so that you can, for instance, serial print and know what's happening. Then the function connect to server, as the name implies, is called anytime that the client is connected to a server. This class, myAdvertiseDevice callbacks, actually is a class that is used when the client is not connected yet to scan for servers. And when it does find a server, it verifies that this server has the services and characteristics that we're looking for so that we can connect to it. Then we go into the actual setup. The setup is relatively straightforward. Of course, we first initialize the serial interface, then we set up the BLE device, and scanning basically starts. In the main loop, of course, we need to make sure that whenever there's a new connection that we attend to this. And if we're connected, we can now do stuff with the variables we receive and or send variables back to the server. This example actually it also sends a value periodically back to the server. Because our server is just only using notify at the moment and doesn't have any read or write implemented, we'll go ahead and for now comment this out. We'll go and use that at a later point in time. With that, let's program this to a second ESP32 and see if the two connect. To verify now whether or not the ESP32 client is connected, we can simply just open the serial interface. Here's the serial interface, and as we can see, it periodically receives data. We can't really interpret the data yet, but that's what we'll do now in a second step. So let's now have a look at the notify callback function. This is the function that gets run every time the server sends a value with notify to the client. We can see here that the reason that the data was a little off is that it thinks that it's receiving a character, whereas we're actually sending an unsigned integer 32. So let's go and fix that. Now we basically just need to convert the 4 bytes that we received to an unsigned integer 32. The easiest way to do this is with bit shifting. Now we can of course manually do that. I'll just show you briefly how that is done. For the sake of time, I'll fast forward this. So this would be the way to implement the bit shifting in a hard-coded fashion. We use OR functions here in between the individual terms to add up the individual bytes. Then the least significant byte, pdata0, is added as is. pdata1 then is bit shifted by 8 bits, so exactly 1 byte. pdata2 is bit shifted by 2, and pdata3 is bit shifted by 3 bytes. 3 bytes meaning 24 bits. You might not always send an unsigned integer 32. So there's a more dynamic way to do this, and that is by just verifying the length of the notification message and then running a for loop to do the bit shifting for you. That would look like this. So how does this work? Similarly, we initialize an unsigned integer 32 counter. We now make it equal to the least significant byte, that's pdata0. And we can now see in the for loop that each byte received gets 8 bits more shift. So shifted by 1 byte extra. That way, in essence, you implement the exact same code as we just saw, but in a more dynamic fashion. Let's leave this in for now and run the code. Oh yeah, but before we run it, the one thing we do want to change here is the printing. We now, of course, want to print our newly reassembled counter. So I'll open up the serial monitor again. So here's the serial monitor of the client ESP32. And we now indeed see integer numbers adding up, well, unsigned int 32 numbers adding up. And you can see that the server has already counted to 3000 since I started making this video. Okay, so as a next step, apart from sending integers, I'm sure you want at some point in time to send strings or characters also from the server to the client. So let's do that next. I'll leave this counter in and we'll just add a string on top, so that you can then use of that whatever you need for your own project. So in order to add the string to the server, I opened the BLE server.ino file again, as you can see on the left top. And here now we need to add another characteristic. I said we leave the integer characteristic in, so we probably just want to go ahead and define p characteristic 1, which is the integer value, and then p characteristic 2, which will be the string. The easiest way to do that is just select this p characteristic and do a find and replace, and we're going to replace it with p characteristic _1. And so we'll go ahead and replace and find. You could just do replace all, then that's taken care of. Then the second thing is, scrolling back on the top, that we're now going to make a p characteristic number 2. So just copy paste this. Go ahead and say p characteristic 2. The same we're going to do with the description and with the BLE 2902. So go ahead and select that, and we'll make a description first, the description 1, replace all. And it always jumps to the last replace all that it did, so you need to briefly scroll back up. And we'll do the same with the PBLE 2902, so Control F. And this one as well. We'll make this 1, replace all. And then we'll go ahead and, at least for the 2902, we do need a second one. So We'll make a second one. We could as well make another descriptor, but just for simplicity, I'll leave it out for now. You can do that yourself if you need one. All right, so then let's see where P characteristic is used. So we select the first one, Control F, and just go find. And then we see that, of course, it's used when we create the BLE characteristic itself. So we go ahead and just copy that and define then a P characteristic too. So Control C, Control V, and we'll make this P characteristic number 2, and it's going to be a service. And we see now that the characteristic UUID needs to be defined here. So we do need to add a new characteristic UUID. So we'll do the same trick. Let's briefly go up. The characteristic UUID is defined over here and here as well. Control F, Control C. We're going to make this characteristic UUID number 2. Oh, wait, sorry, number 1. Replace all. And now we need to define a new characteristic UUID for the second one. So just go ahead and copy that. And we generate that UUID here on this website. So let's just briefly go there. And we'll just copy this. All right, go and throw it in here. You can just generate one yourself, of course. Just click on the link there, etc. All right, so now let's go back to where we were using this characteristic UUID, and then we need to, of course, replace it for the second one. So the first one is used over here, and then this is second characteristic. So we'll go ahead and do 2. That should do. Then, of course, there's the whole set of, the descriptor. As I said, I'll not add another descriptor for P characteristic number 2. But if you want, you can just do that, copy paste this, make a new P descriptor number 2, and you're good to go. What we do need, though, is the BLE 2902. Now, I'll just go ahead and copy paste this and update 1 with 2. Surprise. Okay, so that should do for the setup. Then the next step would be where we're writing periodically and notifying periodically the receiver. We, of course, need to now add some sort of a string or whatever we want to do there. So let's just scroll down to the main loop. And in the main loop, we see here this P characteristic 1 set value. And we can just go ahead and copy these 2 lines. I hope you guys can still follow. I'm not going too fast here. Otherwise, if you're lazy, you can just download, of course, the server from the description below. So let's go ahead and write this to the Arduino and then verify with our mobile phone whether everything's working correctly. So we're checking now again with NRF Connect, and let's connect to the ESP32. And we see our service. And indeed, there's 2 characteristics at the moment. First one's counting, and the second one says, this is a string. Good, we're all set up. Let's leave this ESP running and then focus on the client. Okay, so we're looking here at the BLE client code, and similar to the server, we're going to go ahead and define car UUID, character UUID 1 and 2. In the BLE server, they're called car UUID. So we'll go ahead and Control F that and define a 1, go ahead, replace all, scroll away all the way to the top. And now we need to define the second character UUID that we just introduced in the server. So we'll make that 2 and copy paste the character UUID over from the server. So let's briefly go to the server, copy and paste. Then let's see where character UUID number 1 is used. And we find it here at first in the connect to server function, where whenever you connect to a server, it makes sure that the character UUIDs that you expect are also available at that server. Otherwise, you shouldn't connect to it, of course. Now, while this does work, and we could, of course, now copy paste it, do the whole thing for the second UUID, I just don't think this scales very well. I'm sure you will have more than one character UUID. So why not create just a function that does the connect characteristic validation, and then we can run this for each individual characteristic that we're going to look at. So let's go ahead and select all this basically to the end of the function and move it over to a separate function. So we're going to make a, let's make it a bool that can return true, connect characteristic, and we needed some variables. We'll see that later. All right, so that should do. Let me briefly fix the indenting here. Better. So the first thing we need to do is locally define this pointer p remote characteristic. If we scroll all the way up, then we can see that there is a global definition for this variable because it used to be in the connect to server function. But now that we make a local function from it, let's just take this over and put it over here. In addition, we won't be needing that static. So there we go. And then we see the first variable that we need to pass on into the connect characteristic is this remote service. Let's define that here in the variables. That is BLE remote service, and that's a pointer, and it is called p remote service. Then the next thing we need is the UUID. So that is a BLE UUID, and let's call it here local characteristic UUID. So we go and we need to copy this over here. And I think that's pretty much it. Let's have a look, see if this works now. So we define that, then we see if it is actually available. If it is not available, then it failed to find our characteristic. And it prints then the character UUID and kind of helps if you have the right variable there. Then we disconnect from the client, but actually that is not done in this connect characteristic function. This would then be done after we return false. So basically this should be removed here. And we just return false and then disconnect from the client. Otherwise, we found our characteristic. We can, of course, read out the value of the characteristic, but now that we have either an integer or string, we need to first interpret the UUID and then interpret the appropriate value. And we actually will do that in the callback function just now. So let's just comment it out here. You could make just a general interpretation function afterwards if you want to, but we do notify anyway, so you get periodic updates. And finally, we register the notify callback function. Good. And then, of course, the last thing we'll need to do is return true. With that, we can go back to the connect server fully. So now we can go back to the connect to server section that's above here. And we see this connected is true. Let's start below that. Now let me first fix the indents here because it's a little off. That's better. So now let's verify if our characteristics are present. So we can now run that function. And if this is false, then we're not connected. So now we checked both our characteristic UUIDs, and if we are not connected, then let's make sure that it's disconnected. So we go p client disconnect, and yeah, we can print this as well, of course. So. Then at least we know what went wrong and we return false. And otherwise here we can return true. Okay, that should basically set up our two characteristics, and we can now fully focus on our notify callback function. I think it's kind of confusing how this is written. Let me just fix that a little bit. So this notify callback function has a couple of variables that it got. So the first one is the BLE remote characteristic, and then there's these three over here. Let me just put them below the other variable that at least you can see that those are the variables and it's not part of the code. Actual code just starts over here. And the first thing we can do is now verify which UUID was sent when the notify callback function is called. And then we can interpret the data the right way because we know if it's a string or if it's an integer. So let's do that over here. We can, first let's just check if characteristic UUID1 is sent. So we can do if, and here this print already writes down the characteristic, so we can just get this string and verify now whether or not this equals our character UUID number 1. And let's go to string here as well. In that case, we want to do all this stuff. So the interpretation that we had just now with the counter. We can shorten this also a little bit. Let's remove that. We also can remove the UUID and just say UUID1 of length, and then we have the actual data. Else if, might have written an elif before as well. I guess that is not really what you do here for an else if. Let me just briefly check. Yes, my apologies. This elif, of course, should be an else if. Otherwise, we get a compilation error. So that is in the connect to server function. I briefly wrote an elif. Guess that's a little bit C there. All right, going back to our notify function, where I also just wrote an else if, and we can now copy paste this over here and verify if character ID 2 is sent. If in case character ID number 2 is sent, also here, by the way, the indents are pretty much off. Let me just go like that. Better. If character ID number 2 is sent, it's a string, so we can print that string. Now, as I already explained in part number 1, strings are sent in a way that each byte that is sent is one character. So we need to interpret it as such. So now we can just say serial.print, let's just say here data. And we can now print all the characters that we received. So int I is 0, I smaller than the length, and then I ++ serial dot print, and we need to cast it now to a character, and this should do. And let's put a dot at the end. Okay, so clean this up a little bit. So please don't forget to change the serial port here to the one where the client is now connected. In my case, it's COM number 3, and then write it there. And then let's open the serial monitor and look at the result. And it seems I missed here to close the quotes, so let's now write it again. Now, actually, when I first tried to connect with the second Arduino to the server, it didn't work. It gave me an error. Let me just show you that error. Let me just put off auto scroll and go to the top. So it didn't at first give me any output, so I gave it a reset. And then after the reset, it basically said that there was a HCI packet count mismatch. So I was puzzled. What is that? Turns out my phone was still connected to the server. And because my phone was connected, the ESP32, the second ESP32, couldn't be connected at the same time. And that's why it gave this error. So when I disconnected my phone, then it connected. And now as you can see, it works, and it provides us the string. This is a string, and the integer counting up. So I can put auto scroll on again. So now you can test yourself and see if you really understood how to add characteristics. So why don't you try to add a characteristic for yourself? You can choose whether you want to add a unsigned integer 8 or 16 or 32 or a float. Or maybe you want to add a string. Bear in mind that if you use strings, to use the std string instead of the, I would say, standard Arduino string with capital S. Otherwise, it doesn't work with the set value function. We're now going to go ahead and start working with write and read. And so initially, we'll start with that in the server program. So let's go open up the BLE server and make sure that there's a characteristic that we can read or write with. So here's the BLE server file again. There's not a whole lot of things we need to change here. Let's use p characteristic number 2 to read and write values, and we'll just put off notify for the moment. All right, then the first thing we need to do is to scroll down to the definition of p characteristic 2 and add the fact that we want to be able to read and write. So I went ahead and already copy pasted that in. So that's pretty standard BLE characteristic, and then property read. And then don't forget this or sign over here, otherwise it won't compile. And then there's property write, also with an or sign afterwards. And then the last one is property notify. I said we won't use the notify, but I'll just leave it in for now. Then, yeah, this all stays the same, and we can just go to the main loop. And in the main loop, we now want to start reading and writing variables. So let's first put off the p characteristic 1, because otherwise it'll spam our serial monitor a little bit. And we're now going to focus on p characteristic number 2. And the idea would be to ping pong strings between the server and the client. Then you can choose whatever you need for your own code. So we'll start by just receiving whatever it might have been sent from the client. That we do with, it's going to be a standard string. And let's call it rx value. And then from p characteristic number 2, we just do a get value. That's basically it. We can, of course, now print this value. So let's do a serial print. Just for identification, this is going to be p characteristic number 2, the get value of that. And we then do serial.print ln, that we kind of go to the next line. And rx value, though rx value is this standard string. And if I would go just serial print this, I'll get an error. We need to convert this to something that the Arduino can actually do something with. So the cstring function, you'll see me use that a lot actually, is really useful because it interprets the standard string, converts it to a character array. And that way, serial print can actually do something useful with it. That's basically it. Now we received whatever the client might be sending. As a next step, let's send something over. So we can make a string, and that one we call just a random number from the server, and we add a random number. Let's do 1,000. This way, we just have a string with a random number that we then want to send over. So here we can just leave the set value, and we change this to tx value. Again, this is a string that's not going to work like this. So we need that magic function cstring, and that will convert to standard string. Just for reference, we can also here print serial.print p characteristic number 2, set value, and add the string. In this case, I can just put them all on the same line because tx value is a string, so it's the same type as this over here. That won't work in the case of a converted standard string over here. And speaking about strings, it seems that I forgot to add a semicolon over here. So let's add that quickly, otherwise it won't compile. As we're now reading and writing in between the client and server, we don't need this p characteristic to notify anymore. So go ahead and comment this out. All right, let's program this and then have a look at the client. And here we are with the client code. We can go straight away down to the main loop. And in the main loop, I commented out this part where there was already a bit on writing back to the server, and so we're going to use that later on. So that's now. Let's uncomment that stuff that we commented out earlier. And the first thing we'll need to do here is that we will redefine now that p characteristic. Before we removed it because we didn't need it anymore for the cross-check of whether or not the service was available. Now we need it to be able to refer to the remote characteristic number 2. So let's go all the way to the top. And over here, we can now define a BLE remote characteristic. It's a pointer, and let's call it p remote car2. In fact, we could use this p remote characteristic straight away in the connect characteristic function that we made. At the moment, we give the UUID and create here the p remote characteristics once more. But of course, we could also just pass the pointer to this function, clean it up a little bit. I'll do that on the GitHub, but for now, let's continue as is. As the next step, we'll go to the connect to server function. And right before the end, where we know we're connected, we need to now assign this characteristic to the pointer we just created. So we do here p remote characteristic number 2 equals p remote service get characteristic char UUID 2. That should do. Then we go on to the main loop. Okay, so we now defined our p remote characteristic for characteristic number 2, and we can straight away write a value. So let's clean this up a little bit. I'll call this not new value. I think that's not very descriptive. Let's make it a transmit value, whatever we want to send over. And now this we'll call a random value from the client. Feel free to do something else here, of course, and I'll just add here a random value. And let me make this a negative number, then it's easier to separate the two. We'll then print here as well, let's say p characteristic number 2, write value. This was our transmit value. That's better. And then over here, we need our transmit value as well. So now we wrote to the characteristic, but we actually first want to read before we actually write something there. And that we do, of course, above, and that will be a standard string again. And we'll call it receive value. And as you could guess, we'll just take our p characteristic, remote characteristic number 2, and do a read value. As easy as that. The only thing we need to do then is just print it. Let's just say p characteristic 2 read value value, and print the value itself. Here again, we need the magic cstring function to convert from standard string to something Arduino can use. That's basically it. So with that, let's program this and see if it all works. Okay, and we're up and running. So we can see now on the left the server and on the right the client. We see that the server writes values to the client and the client writes values to the server. Of course, at this point in time, we just periodically write variables. But in your own program, you can, for instance, write a variable if someone in an app changes a number, or if a certain temperature in a certain room is too high in your IoT sensor, or something the like. Here are some pointers in getting you started. So whenever you program the server, it makes sense to restart the client. And if you program the client, it makes sense to restart the server. Now, if you use many windows in the IDE, it can be rather confusing, especially when you have your serial monitor open and it doesn't allow you to program at some points in time. So in that case, just close all the serial monitors, make sure that you write to the right serial port, and document everything very well. So I wish you a lot of fun with this basic BLE communication between server and client. And join me in the next video, part number 3, where we'll make a mobile app and read and write values then to the ESP32. Thank you very much for watching. As usual, likes are well appreciated, and leave your comments down below. See you in the next video.